Welcome back to the channel, everyone. Today we're going to touch on operations with fractions, basic addition, subtraction, multiplication, and division. Okay? So here I'm really going to focus on just subtraction, but these rules still apply for addition and subtraction when we're talking about operations with fractions. Okay? So what we need to find in order to add or subtract fractions, you may remember that we actually have to look at these two pieces. We know that we have a numerator, okay, the number that's on top of the fraction, and then we have our denominator that's in the bottom of that fraction, okay? So essentially, this is just a division problem where we have our numerator is getting divided by our denominator, okay? All right, so what I need to find, though, I can't just subtract this right away. I need to be able to find that these guys in the denominator, I have to have what's called a common denominator, meaning the denominator needs to be the same, okay? So in order to do that, I want to find something you've heard of before, which is a least common multiple between my two denominators here, which in this case is between 6 and 4. So I want to find the least common multiple between 6 and 4. Now, worst case scenario is you just go through and you multiply 6 by 4 and you get a factor of 24. Okay? So that is a common multiple between the two, and sometimes that does work. Okay, so if you are all out of ideas and you don't know your least common multiple, you could certainly go through and find it to be 24. However, we're going to have to reduce far more in the end, and I would like to not have to worry about that. So we're going to think about our factors of 6. So we go from 6, 12, 18, 24, etc. If I look at 4, I have 4, 8, 12, 16, 20, 24, etc. I want the one that intersects between these two that is the smallest for both, which in that case is going to be this number right here, this number 12, okay? So that's what I'm looking for here, and that's what I want to create. That is my least common multiple. So in order to create that, I would have to take this 6 right here, and I would have to multiply it by 2 in order to get a denominator of 12. The same is true for my numerator. I'm going to also multiply that by 2, which is really 2 over 2. And we know mathematically that 2 over 2, any number divided by itself, is physically 1. So I'm just really changing this ever so slightly, just making it look a little bit different, right? So that ends up becoming 10 twelfths. Over here, I'm going to do the same process, but this time I'm multiplying that denominator by 3 and the numerator by 3. So again, it's the same problem. I'm just making it look a little bit different. Denominator is over 12, and then 23 times 3 is 69. I go from there, and now I subtract. I use my integer rules again. So I know my denominator is going to stay the same. It's going to stay as a 12. And then I subtract my numerator. 10 minus 69, is negative 59. We still use those same integer rules where we add and subtract. The last thing I would try to do here is try to reduce this, which actually I can't. 59 being a prime number, I can't actually reduce any of this by a common factor, so I'm actually done right there. Okay. So that's adding and subtracting, same rules apply. Sign rules, the same sign add and keep, different sign subtract, that still applies in here as well. Next is going into multiplication division. So this is where it's a little bit different, okay? Multiplication, we know at bare minimum, first of all, we don't need a common denominator to multiply or divide. That's only addition, subtraction. Here, we could either, if we don't know, we can multiply straight across. So we can multiply numerator by numerator, denominator by denominator. Now, if I do that, I end up getting 147 over 48. And what I know here is that is not a simplified version. I would have to reduce that, but it may take me a while to figure out what the greatest common factor between these two values are. So what I have as a separate way is a simple way that we could call, which is a cross-reduce method. Okay? And cross-reduction, another word we can have there is really cross-division. Okay? So I'm going to look in my numerator on one side, on one fraction, and my denominator on the other. And I'm going to see if diagonally there is a common factor between them. Okay? Well, if I look between 8 and 7, well, the only common factor there is 1, and I'm not going to pull out a 1. A 1 will not change either 8 or 7. However, between 21 and 6, I do have a common factor. I'm going to divide these both by its common factor, which is, in this case, I'm going to just jot down, that's our greatest common factor between the two. It's 3. So I'm going to come up here and I'm going to divide 21 by 3. So I'm crossing out that 21 and writing in what's left. When I divide it by 3, it's a 7. When I divide, same thing down here with a 6, when I divide that by 3, it becomes 2. And now I can just multiply straight across. 7 times 7 is 49. 8 times 6 is 16. And the nice piece about cross reduction is once I actually cross reduce, this is already fully reduced. I may leave it as 49 over 16. Okay? So now we're going to apply that rule, potentially, into our division. So lastly with division, what you have heard before is we have this little method where we actually keep, change, and flip. That will sound familiar from your other classes. What this is called technically, it's called multiplying by the reciprocal. Okay? So what the reciprocal actually is, that's this flip right here. Okay? So in using keep, change, flip, and as a review from what you guys did last year, is I'll come through here, I will keep this fraction the same, make it 12 fifths. I will change division to multiplication, and then we will flip, we will write the reciprocal of 3/10, which ends up becoming 10/3. And now again, I look to cross reduce. So what common factors can I reduce? Well, I look at 5 and 10, they have a common factor of 5. So I'm going to divide 5 by 5, it becomes 1. This 10 becomes 2. And then I'm going to divide, I see 12 and 3. They both have a common factor of 3. 12 divided by 3 is 4. 3 divided by 3 is 1. And now I just multiply straight across. 4 times 2 is 8. 1 times 1 is 1. But we also know that any number over 1 just becomes the whole number itself.